Welcome to the latest episode of IoT Leaders, the podcast that aims to demystify the complex, intriguing world of IoT. My name is Nick Earle, your host, and I'm the CEO of SI, a global IoT company. And today I'm delighted to have as my guest on IoT Leaders Dr. Satyam Priyadarshy. And Satyam works for Halliburton, and his title is a Chief Data Scientist. And he's also a technology fellow at Halliburton. And if that's not enough, he's involved in several startups and is a senior fellow at George Mason University on cybersecurity, as well as an adjunct professor at Georgetown University. So definitely a busy man. And Satyam, very welcome to IoT Leaders podcast.
Thank you, Nick. Thanks for the invite. Certainly, yeah, so a little bit addition to the profile. I'm not no longer with Georgetown, but I moved on and I'm now with Virginia Tech and Oklahoma State and a university in India. So
it sounds like one out and two in.
as a former academics, you never leave academics, you see.
Yeah. So. It's well, I don't know how you find time for all of it, but thank you again for finding time for this half an hour or so that we're probably going to be together today. So Satyam, it's a big subject, and I know when we spoke prior to this, it's a pretty wide-ranging subject as well. So let's try and break it down into pieces. Maybe I can just ask you perhaps just a little bit about your own background before we dive in. What was your journey like? How did you get to where you are today, being chief data scientist for Halliburton? And perhaps for those people who don't know Halliburton, because most people do, but there will be people who don't, maybe just a little bit of overview of what Halliburton does in the oil and gas value chain.
So first of all, let's talk about Halliburton, then I'll talk about my journey. Halliburton is 102 years old company. It's one of the world's largest energy services company. I think one of the first patent the company filed was in areas of cementing by Mr. Halliburton, and that's the company named after him. It has over the decades and 100 years, it has gone through a lot of expansion in different fields. But primarily, it is a company which actually collaborates and engineers solutions to maximize the asset value. Now, right. It's a very important part to remember. It's about maximizing the asset value. Now, in olden days, we would just call the hydrocarbon as an asset, but in today's world, data becomes another asset.
So okay, so it's not just what's in the ground under the ocean, but the data is increasingly becoming an asset, which is absolutely where we're going to go, right?
Absolutely. So, as such, the company is global. We have about 50,000 people around the world, pretty much representing most nationalities in the world. And of course, the challenging task of drilling, completion, exploration, all are very complex, scientific and engineering based. So a lot of highly skilled people are in the company as well. So it's a great place in that sense because you get to interact with mathematics, engineers, scientists, physicists, geophysicists. If you look at the spectrum of talent that is there in the company is significant.
Your own journey?
So on my own journey, so I did my PhD in quantum mechanics, applied to biophysics when I was pretty young, and pretty concept of if you think in a very simple terms, solar cells, we make an efficiency of 15% to 25%, but nature makes solar cells with almost 100% efficiency. So my PhD was trying to understand what is going on inside a chloroplast from a quantum mechanical point of view. But I think I was way too ahead of the curve because it just can't compute anything because it involved a computation of 5,000 by 5,000 metrics. And on a non-sparse matrix, you can't compute easily because there were no supercomputers then. And even today, non-sparse matrix is the challenge. And then I switched on and I was trained by an advisor. I think I owe my success to him a lot because he trained me in such a way that you think of a problem not as single problem, it's a multiple problem issue. and you should always be open to addressing multiple problems at the same time. And as a result, in fact, during my PhD, he said not to work on, he won't give me his PhD unless I publish more than topic, so which is really good because it opens up your mind to different problems. And so I went and switched not careers, I went to postdoc, like did 2 postdocs in Australia, in a totally different field like glassy dynamics and lipid membranes. And then I came to US and did work in DNA electron transfer and non-linear optics and many other topics. So we have a very special model called Satyam and Priyadarshy model for DNA electron transfer. But then I did a lot of supercomputing. But if you think of foundation is all in data, being quantum mechanist, you generate a lot of data. And here I was the generator of the data as well as analyzing that data for very complex problems. And so I switched my careers from there to become a technologist at a company called AOL, which is America Online, that brought internet to homes. And I was lucky there that 7 years I went from a individual contributor to becoming head of research in 2005, 2000, and set up AI Center of Excellence in 2005 in Beijing and Bangalore. Then I did my MBA during that time and switched my careers again to become an executive, turn around some companies, got involved in startups. And as a result, one day I got a call from Halliburton, or a recruiter from oil and gas industry said they're looking for someone like this. And with this experience, I am having fun for last 7 years in Halliburton, where I set up my Center of Excellence for Big Data, Data Science, and Digital in 2014 when nobody was thinking about it in the industry.
Well, there's enough material there for about 20 podcasts. From chloroplasts and to Halliburton and big data. So let's just pick that last subject and go deep, because you said there interesting. You said that nobody was thinking about it a while ago. And in the subject of IoT, of course, a lot of people say, well, actually the product from IoT is the data. Although it would seem to me that certainly in the field that you're in, there's no shortage of data. There may well be a shortage of insight as to what it actually means, but it seems like the amount of data that we're now technically able to create, I mean, it's not a dripping tap or even a running tap. It's not even a hose pipe. It appears to be almost like a tsunami, and it's only going to get more and more and more. I guess your work must rotate around that in terms of how on earth do you make sense and insight and interpret this data that is coming at us in the context of the business value of the data itself.
Absolutely. So, people can challenge my comment that people are not thinking about it, but that is to an extent true. But the industry has been generating data, no doubt about it, right? But if you talk to experts, they will say that, oh, even today, we are talking about 2021, people will say, oh, data is of not good quality, data is not complete. So if you think of where the world is, and if we look at data native companies, which AOL was one of them, and now the Googles of the world, you can call them. Now, if they also had the same problem of data not complete and of bad quality, then they would not be making money.
Yeah.
Right? Because the money comes by analyzing the data, building recommendation engine, whatever it is. Now, if in an engineering firm, we keep saying that data is of not good quality, then what have we done to fix that? Right? And that's where I think we'll come back to more details later. I think the IoTs or the industrial IoT will really make sense because that can actually improve the quality of the data, right? Now, industry collected the data, no doubt, a significant amount from exploration to drilling and completion and HSE and other areas. But if you look at it, the data was collected in the field. It was transmitted to the back office at a certain frequency. So not all the data was ever moved to back office, but if it was moved in a later stage, so to say. So there was no real time, so to say, analysis of it to the extent that it could have been done. Now, so if you look at even the last 20 years, evolution of the technology, for example, search technology. Like we all depend on it, right? For all our practical life, we depend on it. But when it comes to implementation in the energy sector, that has been really poor.
Right.
If you go to any of the big energy companies and you want to search for a, say, a rotatory pump that you have used for last 10 years and you have repaired it 20 times, and if you want to search for that repair log, you will not find it.
Why we hear these stories a lot about, um, it's almost a paradox in a way, the companies that arguably could benefit the most from the data, like this device has broken 20 times on the run, it's now broken for the 21st time. Can I just find out what to do? And that would save me a lot of money. And there's so much money involved, and oil exploration, for example, is massively capital intensive. It's a very expensive business. It's all about collapsing the time. You hear these stories, and then you also hear, not just Halliburton, but large companies in general often are not the ones who have captured the learnings, captured the knowledge, and they are to some extent behind the curve. Why is that? Is it a cultural thing? Is it? Do you believe, is it a volume of data thing? Is it that they were just focusing on something else as a priority, like finding the oil and gas? Why do you think that is?
So I think my take on that is that, while this technology evolved, the industry did not spend any did not spend well on actually understanding this technology well, right? So whoever, a vendor came and said, oh, here is my search platform, you can implement it to search your corporate website.
Yeah.
And that's what got implemented. Nobody looked at the use case, how it could be really be done for other areas or on top of a database, right? So those were not thought about very well, that how the value will come. And also one of the it's a kind of a cultural thing, and call it a business strategy. When you are in an operational mode, your goal is to fix the problem and move on.
Yes.
But if you look at the whole framework of data science, is that you want to do the science on the data. That means your historical data is your really good source to do that science experiment. Right? Because you already broke, your pump already broke.
Yeah, you have the data then. Yeah.
But now I can actually analyze that data and understand that for last 5 times, why did it break? So that I can avoid those situations or those conditions, or can address those conditions well in advance before it happens the next time. So the thought process has to be there, that historical data has significant value, and that value could be measured. And in fact, when we did some experiments, I would call them experiments, in early 2014, we showed that how much value it is there in terms of monetary value that the organizations or the industry has lost. And
so they're sitting on an asset. Yeah, sorry, they're sitting on an asset, a huge asset, which is historical data. But in general, people are not looking in that direction for the value. They're looking in the other direction for all the new things, the shiny new toy, what they're doing next, new implementations. But actually, there's a lot of value in the legacy data that's just sitting around the storage.
And I'm sure in your interaction, you must have come to people asking the question, who owns the data?
Yes.
Right now, if you think of as a business and you being a CEO, so if in principle, the company owns the data.
Yeah.
Right. So why this question about who owns the data within a company? So when you start thinking that the data is owned by the company, then you start analyzing it. And that means people should start collaborating. In fact, I wrote an article 2015, I think, called Data Democratization. And initially there was a pushback saying, we can't talk about these things. But democratization doesn't mean to give away. How can we look at the data, right? You are in a workflow, you have first 3 steps worth of data, somebody has another next 3 steps worth of data. When you look at the whole workflow holistically, then only you can create value. When you are doing things in a silo, you really can't create value too much. Right? It's
so how, excuse me, Satyam, how I mean, there's value the analogy I've got in my mind is like there's gold under our feet. We just can't get hold of it. But there's value in the data. There's huge amounts of data. It's owned by the company, but it's not like there's any issues in accessing the data. It's already their data. So where do you start? It seems like what you're addressing, your role in Halliburton, is to solve a very big problem, but a very important problem and a very valuable problem to solve. But it's also a very broad problem. I mean, there's data everywhere. I mean, it's everywhere, and we're creating it at an ever increasing value. So, what advice would you give on other people who are perhaps listening to this, thinking, well, yeah, my company's in the same situation, and we've got all this data, and we've got all this new data we're now getting with all this new technology and sensors. How do you go about getting a strategy to mine the value?
Yeah, so you see, what I have been doing, and for last 7 years, I'll say from that practice, and I've been done this for other industry before, so I know that it works. You see, one is you have as a CEO or as a people under CEO, people already know where the serious problems are at
Yes.
a tacit knowledge. They may not have a quantification of it precisely because it's
But if you
hard.
ask them, they've got a good idea.
Exactly. Otherwise, they wouldn't be in that seat.
Yeah.
Right. So you look at the experts saying, okay, in the last 5 years, 6 years, what thing could have been really improved? And then you break down the problem into what you call the sprints, as we call. You want to run that marathon, but you want to break down in sprints and saying, okay, I will let's take this example that I started with of a rotatory pump, right? If you have deployed that pump for 20 times and it has broken, or say at a rough tacit knowledge perspective, it has broken after every 3 months of deployment.
Yeah.
You have some idea that it breaks after 3 months. Now I want to really narrow down that problem. Why does it happen? So you come up with a solution in a way that I can look at the data close to the 3-month period, 5 days before, or 10 days before, or 20 days before, and see what happened really in that operation. So what you do is you take a business problem, which is, you can say, I will save $50 million, let's say. And then you break it down, that problem, into chunks, and saying, I'm going to look at a problem which I can take a data over 6 months. And if I can generate 2% of that savings, then it's a problem worth solving. So the concept that I say is that look at the data from a proof of value product, not proof of concept. Concept is well known, that data works, the data science works, right? And the data that you have, actually, how much value does it have? And then you start integrating data from many places. Saying, for example, if it is a pump, you can connect weather data, you can connect, if possible, HR data, right? Or connect your chemicals data, you can connect your deployment, repair log, parts log, whatever it is. You start connecting different data sets, saying, oh, whenever we replace a bearing of this model, it fails. So you have to start asking questions from the data and then adding on more data sets. So you do it in a step-by-step fashion.
Right.
So first phase should be less than around 16 weeks or less, on a very small amount of data, where you show, yes, the data has some value. Then you add more data. Then you do another small project called proof of value. Then you say, I need these 5 more data sets to connect to it. They could be under different silos. And then you scale the problem. So by the third step, you already know how much value you are going to generate, either in cost savings or revenue generation or accuracy or efficiency or NPV. So it is anything you do with data has always value. So you may have heard people saying, oh, my digital project failed, or my data science project failed. I don't believe in that at all, because no projects fail, because every project has a value. You could not scale it. That's a different issue.
Well, actually, some of the data that as my company, SI, that I run, and every other IoT company knows that actually the data on the failure rate for IoT projects is appalling. Some of the industry analysts have talked about 80% of IoT projects never make it past the POC. And when you double click on that, the proof of concept, and when you double click on that, it's actually not really a technical problem. There are issues definitely to do with the device. Most people don't know anything about hardware design and don't want to know anything about hardware design, and that's a gap that we filled working with the module manufacturers, for instance, the Quectels of the world, the Gemaltos of the world. But also, it fails because they suddenly, it's like turning a tap on, they suddenly start collecting a lot of data. And that's the point at which they just freeze. I mean, they can't measure the quality of what they're getting. They don't know which data is important, which data is not important. They haven't got an architecture for what do they process at the edge, what data do they backhaul. If they send it all back to head office, particularly I would imagine if you're in an oil field or on a rig or something, the amount of data, terabytes, petabytes, and beyond, the amount of, you just can't afford to send it back to your corporate headquarters to crunch it. So you've got to do edge processing, and they just didn't think about the problems of a data architecture and big data and insight when they started their project. And so that you do see what you're saying in the general statistics on the industry, in that people, they don't start off with trying to drill it down to, let's just try and find out one particular problem and go chase down that one particular problem. Often they start off with a horizontal approach and say, let's collect data from as many things as possible, and then we'll work out what to do with our data. And that's when often they just freeze and they think, I don't know what to do with this. I'm collecting data, but I don't know what I'm going to do with it.
Yeah, absolutely. But my philosophy has been very different. We can address as big as of a problem, right? In today's environment, when IoT sensors or any device that is generating the data can be in any format today's world, because compute is so cheap,
Yeah.
right? And in principle, you could really put out very, what I should call, powerful machines at the edge as well, in a very small factor. So you don't have to really backhaul everything.
Yeah.
Right? Whether it's cloud or edge or whatever you want to call it, fog node, and you can do that, right? You can develop the algorithms or the models, whether it's scientific or augmented models, and you can push them back to the field. Where the challenge comes is that we really can't make automated yet, because we have to really test anything we do in the field. In any complex industry, you really have to test and validate more often than anything. It's right, the models are models after all, and more validation is done. But the size of the data should not be a concern, because if that was a concern, then, as I said, data native companies will not exist.
Because
so that problem has been solved.
The compute is accelerating fast enough so that it's not an inhibitor, just because of the amount of, especially with cloud, the amount of processing power that's available. It's not a blockage in the process, is what you're saying.
Absolutely.
Yeah.
It's more about a business problem that we want to solve, and whether I need to really look at the data from 1 month, or should I just only look at a 1 week, because depending on the workflow we are talking, we could be really creating more value within 1 week's period of worth of data, and should be good enough for us, right? Or something we might have to look beyond it. So most of the things we want to eventually do in real time. And so that means you don't really have to process petabytes of data all the time, because we are not any of this industry. Maybe say refineries, if they were to deploy 40,000 sensors, maybe they will get a data in terabytes, because no IoT sensor sends data in gigabytes per day. Right?
I heard a statistic that and I don't know how up to date this is, but I'm probably speaking to the person who does. An oil rig, I heard, and it was a few years ago, an oil rig, an oil refinery could have 10 million sensors in it. Now, I've got a feeling that's about a 4 or 5 year old statistic. Is that is that broadly there, or too small, too big? What would you say?
So I've been, these are numbers written by a lot of people. I'm not sure. I've never seen them before. Like, I've not been to a field, so I can't say that for sure. But how do they calculate, and what does the device means? What does the sensor mean? Are they really Internet of Things devices, or there are any devices, right? So by definition, anything that is connected becomes an Internet of a thing or internet, right? But if you have pumps that are running and generating data which is collected by hand, that's not an Internet of a thing, but it is the data.
Right. Yeah.
Right. So these when people write these kind of articles, I don't know how many of them have really counted what is connected and what is not connected.
Almost certainly nobody. I mean, we're in
Right.
the IoT business, and we have customers in the oil and gas. And let me tell you, in terms of true IoT devices, as opposed to something with a controller in it that's able to spit out data which isn't IoT, but in terms of true IoT devices, it's probably in the hundreds in practical terms today. I mean, it's nowhere near that. It
Absolutely.
might be in the future with maybe with 5G, when we start getting private 5G networks in these locations. But even then, I think the word or the phrase IoT is being stretched to cover everything electronic, and that's not what we're talking about. In fact, it's counterproductive to think that that's what we're talking about.
Absolutely. And I think, again, it's a future of the when everything becomes digital, maybe that is when we will get that kind of sensors, the count of sensors and connectivity, but we are nowhere close to that, right? And if you look at oil and gas industry, they talked about digital oil fields 25 years ago or something,
Yeah.
and integrated reservoir management some 30 years ago. So what is integrated and what is which digital oil field really exists, right? Because foundation, when you say digital oil field, if everything is connected and you are doing real time automation, that's then it becomes really valued. But pieces of the puzzle are automated, no doubt about it. But we don't have a fully holistic, automated digital oil fields.
Well, another thing people said, and that allows us to transition to perhaps one of the final big subjects, was um, again, if you talked about 30 years ago, 20 years ago, but let's just say 5 years ago, people would say, well, the answer to this is nothing to do with the human, as you were saying. People would say, by now or in the future, shortly, it's all going to be artificial intelligence. It's going to be machine learning. The machines will take over. The humans will let go. They'll stand back. We were worrying about what are we going to do for jobs, because it's all going to be, the machines are going to beat the humans at the analysis. They can learn about the pumps breaking. They can learn about the resolution. They can give you from reactive to proactive, preemptive. I mean, that's what they see in people's cars. They see it, it would break, and so you take it somewhere to be fixed, and then that would be reactive. And proactive, a light would go on saying it's going to break, like it's going to run out of oil, so put oil in before it breaks. And preemptive, the Tesla, you get in the car at the moment, get in the car, and it's like the iPhone, while you were asleep, software update downloaded. We fixed a whole bunch of issues you never even knew you had, but don't worry, you'll never have them anyway. Have a nice day. So by now, we were going to be in this world where, or at least entering into this world where the machines had taken over. Now, I know when we spoke previously, and I can see you smiling there, and I know when we spoke, you have your doubts whether or not the world of AI. In fact, you even said to me you didn't even like the phrase AI. Because of your experience. Maybe you could expand on that a little bit.
Yeah, so artificial intelligence by itself as a subject has been there for 50 plus years.
Right.
And if you look at even the applications of algorithms that are developed, has been used by oil and gas industry for last 45 years. Whether it's neural network, whether it is regression, right? It doesn't matter which algorithm you're talking about. The world changed on the technology side and the compute side. And artificial intelligence is just a subject, right? It's like my analogy that I always explain. We never say that we are eating chemistry or we are wearing chemistry, right? We are all clothes are made out of chemicals. Food is made out of chemicals.
Right.
There's some chemistry going on, right?
Yeah.
Application of chemistry that we are talking about. So it's in the same way, it's an application of artificial intelligence, whether it's related to audio, whether it's related to video, whether it's related to data, whether it's related to text, right? That is what we are talking. So there is nothing, there is no box called artificial
No
intelligence.
thing. There's no
No
thing that's
thing.
independent to everything else.
And when these articles come out saying artificial intelligence in Tesla, is that the same box? Can I put it on my computer for doing my statistical analysis? No, right? So it is not a thing. And that's where the confusion is. But irrespective of that, okay, it's a field and it's important field, and it allows you to analyze things that human beings by themselves could not do. Right, at scale, repeated tasks that can be optimized, and even can eventually, when self-learning algorithms will be there, more mature, then maybe things can actually improve. Like you can see those examples in robotics a little bit, where the robot can learn and things like that. But where are we? We are far away from it in terms of application. Maybe in some defense sector things that we don't know, who knows what's going on there. But in a practical world, that's nowhere close to it, because it requires in principle all the tacit knowledge that is sitting in your head and all the people who are actually in the field, right? What to do when, that is in people's and engineers head after 20, 30, 40, 50 years of experience.
And there's no substitute for that.
And if you look at the history of knowledge management in the companies, we have never figured out a way to capture the tacit knowledge.
Tacit knowledge, yeah.
And that tacit knowledge is what algorithms will need to really make a decision.
So back to your example about the pumps, you talked about asking the engineer who perhaps have been around for ages, saying, well, if I was going to investigate, double click on one area, what would it be? That experienced engineer would say, oh, you really want to have a look at these pumps because they break every 3 months and it's a really big issue. And that comes from just their experience, their tacit knowledge. The chances of the computer system saying that to you are probably pretty low. And then when they do present with the data, they need that tacit knowledge, that experience, that thing that we can't codify to actually interpret the data and prioritize the actions. And so it's you're saying, I guess it's a combination of the two.
Absolutely, a very important combination, especially in oil and gas industry, having worked in and consulted in almost 7-8 verticals before I came here. And I can tell you, in oil and gas industry, the people have so much knowledge because the processes are complex, irrespective of what section of the workflow we talk about. In general, the energy sector, if you look at it, it's a very what you call science and engineering driven industry. And so a lot of these people have so much tacit knowledge in them that really needs to be captured and can be taken advantage of. For example, when you are drilling, right, if you think of it, the person can feel and say, I need to rotate this much, the drill bit.
Yes.
Now, to get a algorithm to do that, you have to really look at so many things. First, you have to understand what is the force coming back, you see, and then you have to really analyze what I did in the past few scenarios like that. So it will take some time. And that's where I'm saying that but on the other hand, those people who are experts, they have this sense that they see the sound or they feel the vibration and they say, do this. Now, they don't believe the data. The data people don't have the same knowledge as the engineer, so they have to come together. And I feel that the people who have the tacit knowledge, they can be trained with the data knowledge, and that is what I call the talent transformation process.
Not the other way around.
The other way around is hard because you can't get the field experience, right?
Yes. Yeah.
You can only get what the field people tell you.
Yeah.
But the field people have so much. So you really need to show them a graph saying this is what's happening here. What do I do? And then you codify that. So that talent transformation.
Excuse me. One last question, because this opens up so many different questions. The combination of the field experience to give you the tacit knowledge and the ability to make that instinctive human judgment that says this is right or this is wrong, the vibration, it feels right, doesn't feel right. We don't know where it comes from, but we can do it. And then the machine playing its role, analyzing things very, very quickly as well. Does that mean that in your role at Halliburton, do you train people? Do you recruit different types of people for the world that we're heading into? Do you look for certain types of degrees? I'm reminded, listening to you, not in the field of oil and gas, but conversations certainly I've been involved in for many, many years, lots of different industries that I've worked in. People are saying, MBA students are useless because they don't have any of the practical experience, but whereas of course the MBA schools all think that they train the future leaders, and everyone's got all the knowledge they would ever need because they've got an MBA. Now you take that and you've now applied it to an oil engineer. So, and often, like in the case of our daughter went to work for several years, then did an MBA, and actually she felt at least she was much more valuable at the end of that than if she'd have done it the other way around. So do you, in Halliburton, make recommendations in terms of what types of people you employ, given this world that we're in already and heading more into, or do you actually run internal training courses on how to get this combination of the machine and the tacit and the human working in harmony?
Yeah, so I'll answer all those parts in a interesting way. So as an academic professor, all my students, for MBA especially, I tell them there's no point doing MBA after bachelor's. Get a couple of years of experience, then do an MBA, then you will know what mistakes I did or what you didn't do, right?
She got it right.
Then the value of MBA becomes really important. Otherwise, it's like taking any other course. You passed it and you're done, right? Yeah. And that's my first recommendation to most people. In terms of, since my background was not a direct oil and gas, so I know that it's all about generating value from the data. And I think in that way, most of the team that I built initially are all people from different fields of science or engineering or other areas. So I have a PhD in atomic physics / astrophysics. I have a PhD in chemical engineering, mathematics, economics, things like that. So they can think totally differently. But then you pair them up with the tacit knowledge people, the subject matter experts, that helps. And then over the years, we actually developed our own training program, not only for individual contributors, but all the way to the leadership. Because one is, you have to really keep these people also in-house, right? There's interesting challenges in the world. And if especially a data science people, they're high in demand.
They're highly valued. There's a lot of jobs out there offering future riches.
Exactly. So the way my philosophy has been that for all the data scientists, give them interesting problems. Don't give them and put them in a box and do just one problem. If they are doing multiple problems at the same time, there's no problem with that. In fact, they love it because then they can think of it, oh, I have this kind of data, or these are the algorithms working, but I have this kind of data. Why is this not working? So they have their own compare and contrast going on within themselves. And then they're interacting with different domain experts, so to say. And that helps them really think beyond a simple problem. And then it's an exciting environment to work. And that's how we have grown this center in Bangalore and in Houston and Colombia and many other places. We are working with so many people. But the training part we developed is because the same people who are actually working on a problem, they are actually teaching the house of this field to the domain experts. So when they ask questions, they learn from the domain expert. Why are they asking this question? Why can't I find this? And when the domain expert says how to do mathematically or why it is like this, they can explain it. And that this synergy is significant. And I think just in the last 2 years, I think we have trained over 1,000 people in the industry.
Wow.
So, and hence, I don't really worry about the talent pool side of it. In fact, I'm one of the hats I wear is the managing director of India Center. And in the last 1 year, I've hired roughly about 100 people from all different fields. So it's a fascinating area to work in. And I think the potential is significant. As I say, the opportunities are significant because we are only scratched the surface of the industry. And if we really have the desire to build full implementation of IoT sensors properly, getting the 5G network working or beyond 5G working, which will reduce the cost to move the data and bring the speed to the connectivity. Then I think we will have to build what is called the digital twin of digital twins. And so that's a fascinating field. And of course, the tacit knowledge is not going anywhere. It is, I call it augmented analysis going on.
Yeah, well, it's a fascinating story. It's a fascinating journey, and it's also reflective of some way of Halliburton's journey as a company into moving more into data and data services for the clients, and as you say, all the efficiencies. And then the whole subject of digital twins is something that we do plan to cover as well in a future podcast. But for the moment, we better leave it there because we've covered so much ground. So maybe I can just finish by Satyam, thanking you for your time and sharing with our listeners your journey, what you're doing, and your thoughts on how to go about it, and for also assuaging those people who perhaps were out there being concerned about whether the machines will take over, that actually you don't believe that they will, and that we're all going to have plenty to do going forward in future years. So with that, I just want to say thanks to everyone for listening. You've been listening to the IoT Leaders podcast with me, your host, Nicole. If you have any feedback or questions on it, remember that we do have an email address, which is iotleaders@si, that's ESEYE.com. So we'd love to hear from you. Any suggestions on any subjects that you would like us to cover. As you heard from this particular podcast, we can actually go very broad or even vertical into industry. And we'd love to hear from you as to what you would like to have a discussion about, or even whether you feel you would like to be a guest on the show. So let's leave it there. Satyam, thank you very much for your time, and for our listeners, we'll see you and talk to you on the next episode. Thanks very much.
Thank you, Nick.